Hello and welcome to G Fun Facts Online, where we dive into the most fascinating science from across the universe. Today, we're looking at the most violent places in the cosmos. Imagine stars exploding with unimaginable force, black holes swallowing matter, and mysterious cosmic rays zipping through space with more energy than anything we could ever create on Earth. For a long time, we thought the only way to see these high-energy events was from space. But what if I told you we're entering a new golden age of astronomy by using the ground beneath our feet? Get ready, because we're peering into the universe's most violent events using revolutionary sensors right here on Earth. So how does it work? Well, there's a problem. The very atmosphere that protects us from all this crazy high-energy radiation also blocks it from reaching our telescopes on the ground. But physicists are clever. They realized they could turn this problem into a solution. When a super high-energy particle, like a gamma ray, smashes into our upper atmosphere, it creates a cascade of secondary particles called an extensive air shower. Think of it like a cosmic firework display, invisible to our eyes, that rains down towards the surface at nearly the speed of light. Ground-based observatories are built to catch the faint signatures of these showers. There are two main ways they do this. The first is with something called a water Cherenkov detector. Picture huge, football field-sized arrays of tanks filled with ultra-pure water. When particles from the air shower zip through this water faster than the speed of light in water, they produce a faint, ghostly blue flash called Cherenkov radiation. Highly sensitive light sensors in the tanks detect these flashes, and by timing them across the whole array, scientists can figure out where the original cosmic particle came from and how much energy it had. The second method uses imaging atmospheric Cherenkov telescopes, or IACTs. Instead of using water, these observatories use massive mirrors to collect that same Cherenkov light, but they catch it as it's being produced in the atmosphere itself. The mirrors focus this faint light onto a super-sensitive camera, creating an image of the particle shower. The shape of that image tells scientists everything they need to know. Now, this is where the real revolution is happening. The technology inside these observatories is getting a massive upgrade. The biggest game changer is a new type of sensor called a silicon photomultiplier, or SiPM. These tiny, powerful semiconductor devices are replacing the older, more fragile sensors. SiPMs are more robust, use less power, and are way more sensitive to the specific blue light of Cherenkov radiation. This means our new telescopes can spot even fainter signals. And here's a huge bonus: they can even operate during moonlight, which could potentially double their observation time. But that's not all. Scientists are also adding radio antennas to these observatories. As the particles in an air shower are bent by Earth's magnetic field, they emit faint radio waves. By listening for these radio whispers, we get another, complementary way to measure the cosmic rays. Some future observatories are planning hybrid designs, combining water tanks and radio antennas to get the most complete picture possible. Even the telescope designs are evolving, with new dual-mirror systems that provide a wider field of view and sharper images than ever before. So with all this new tech, what are we finding? We're starting to solve some of the biggest mysteries in astrophysics. For decades, we've searched for the origin of the most energetic particles from our own galaxy. We've been hunting for so-called PeVatrons, cosmic particle accelerators that can boost particles to a PeV, which is a quadrillion electron volts. And thanks to new observatories like LHAASO in China, we've found them. LHAASO recently detected gamma rays with energies up to 1.4 PeV, giving us the first clear proof that these galactic supercolliders are real. We're also discovering totally new sources of high-energy radiation. Data from the HAWC Observatory in Mexico recently showed that microquasars, which are like miniature versions of the giant quasars at the center of galaxies, can blast out incredibly high-energy gamma rays. This was a huge surprise, challenging the idea that only the biggest, most extreme objects could do that. And what does the future hold? It's incredibly bright. The Cherenkov Telescope Array, or CTA, is under construction and will be 10 times more sensitive than any current instrument. It will have sights in both the northern and southern hemispheres, giving us a full sky view. Following that, the planned Southern Wide Field Gamma Ray Observatory, or SWGO, will complement CTA, ensuring we don't miss any transient events like gamma ray bursts. By combining novel sensors with a new generation of powerful ground-based observatories, we are unlocking the secrets of the universe's most extreme environments, all without ever leaving Earth. Thanks for tuning in to G Fun Facts Online. Stay curious, and we'll see you next time.